Okay, now number 1, most of you got right, so that's excellent. But a few people missed it. So let me just do it, but I'll do it more. Okay, so this is a chain rule. So it's the derivative of the outside. And then you keep the inside. Oops. Okay, that was not helpful. That's interesting. Okay. Okay. I don't know what happened there, sorry. Okay, keep the inside inside. And then multiply by the derivative of the inside. Okay, so that answer, and the derivative of sine is positive cosine, so that answer is E. Okay, number 2, the position of the particle is moving parametric equations. This is not on the 2020 exam. Okay, I'm going to do it anyway because you still need to know it for college. Okay, so position of the particle is given by these parametric equations, at which point is the particle at rest. Okay, so to be at rest, we would need the velocity to be 0. Now that's interesting. How are you going to get a vector to be 0? So I need it not to be moving up, and I need it not to be moving sideways. So I actually need dx dt to be 0, and I also need dy dt to be 0. Okay, so it's really not about the slope for this one. Okay, it's really about a vector, so the velocity vector. Okay, so this is just my ideas, and then here's my execution. Okay, so here's the velocity vector. So the velocity vector, I would take the derivative of the x of t, and I would take the derivative of the y of t. And that would be, this is non-calculator section, minus 6t, and then the derivative of the y is 12 minus 6t. And this one was 71% of you got it right, so definitely some of you missed it. Okay, so this one, we want the particle to be at rest, so I do need both parts to be 0. I actually need it to be the 0 vector, which we've never discussed. But what the vector 0 is that I need both components to be 0, which matches the idea I put over here. Okay, so I need 3t squared minus 6t to equal 0, and I also need 12 minus 6t to equal 0. Okay, so this one is negative 6t equals negative 12, divide by negative 6, and you get t equals 2. This one, maybe GCF out of 3t, so t minus 2. You might hear the train in the background. I decided I would enjoy a sunset while doing math problems today, and so I figured, why not, right? No reason not to. Anyway, so I'm outside in my backyard instead of in my house. Okay, so t equals 0, plus 2, t equals 2. Now, I need both to be true. So for both to be true, it's going to have to be the t equals 2. Okay, so not the t equals 0 because the y prime of t is not 0 at that location. Okay, let's see, number 2. So that is the answer, t equals 2. Okay, so now that I have t, what am I going to do with that information? Okay, so what I'm going to do with that information is I need to find the x value, so x of 2, and I also need to find the y value, y of 2. So x of 2, I would substitute 2 into the equation. So that's 8 minus 12, which is negative 4. And then y of 2 is 12 times 2 minus 3 times 2 squared. Remember, you do exponents first and then multiply. So 24 minus that is 12. So the xy coordinate would be negative 4 and then 12. If you did want the slope, which is not applicable to this problem, it would be dy dx, and that's dy dt divided by dx dt. Okay, but this would be for college because none of this is on our exam this year. I thought you still might like to know how to do it, though, so I figured we would still go over it. Okay, so let's see. That's it for those two. Let me go on to number 3. Okay, so number 3, 79%. So about 1 in every 5 of you missed this one. Okay, but that's still a pretty good percent. Usually in class we wouldn't go over this one and you'd be able to figure it out yourself, but I like this. Might as well, right? I have time. Okay, I don't know if you can hear the birds. So I see birds. I see a sunset. It's pretty awesome. Doing math. How lucky am I? Okay. Very cool. Okay. With my tablet, I could take a picture of the sunset. I'll take a picture next time. Okay, so let's see. The graph, value, integral. Okay, now integral is like area. Okay, but it's signed area. Okay, so what signed area means is below the x-axis counts negative. Okay, because really you're adding up y values and you're adding up negative y values. So I'm going to separate this blue part, and it looks like the width is 2. This is 1. And the depth here is -3. And I could just put regular 3. But when you multiply them, you get -6. Or you could think +6. But later I'm going to have to make it negative anyway because it's below. And then this one, I don't know, should I do a trapezoid? I guess we should memorize the trapezoid formula. I might do 2 triangles, a rectangle and a triangle, if I was doing this on the exam. Oh, there's a bird. Oh, that's cool. That's awesome. Okay, so I'm going to do the trapezoids because you might need to know the trapezoids on your test, and you might not have been on trapezoid for a while. So let me use the trapezoid formula. Okay, so the trapezoid formula from geometry is this, but that's a trapezoid that goes like this, and this is the height, and this is base 1, and this is base 2. But I usually do a calculus trapezoid when I'm using the trapezoidal formula, and I call it width and then height 1 plus height 2. And see if you see why I say that. So here's a trapezoid, right? So this would be height 1, this is height 2, which are playing the role of the bases, and then this would be the width. So usually trapezoids in our in this stuff turns out to be that. So that's what I'll do. So this one, the area of this one would be 1/2 the width. So the width is 2, and then height 1 would be 1, and height 2 would be 5. Okay, so let me color code this for you. Okay, so this 1 is because this is 1. This 5 here is because this is 5. And that's 5 because this is 5. Okay, so let me color code. Okay, and then the width is 2. So that's the width, and that's the answer. So let's work that out. Okay, so this cancels, right? So that's 6. So that is the area of the trapezoid, +6, because it's above. And then I have my -6, which is below, and so overall I should get 0, which is B. So let's see. B3. Yep, that's the answer. How fun. I love to do math problems. Okay, number 4. Which of the following integrals gives the length of the curve? Okay, this is not on the exam in 2020, unless we hear new information on Friday. We've asked, can you just leave everything on the exam and then let the students choose? But I don't know if they're going to say yes or if they're going to say no. Probably they're going to say no, because they did say that this material would not be on the exam. Okay, so length of the curve is, but again, you might need to know it for the future. So length of the curve, there's 3 different formulas that you can use. You can use 1 plus f prime of x squared. You can use 1 plus g prime of x squared. Or you can use dx dt. Let me show you the other one. We'll put or. You could also use this. So this would be for college, because this year we don't expect that it's going to be on the exam. But like I said, we'll know more Friday. You can also use this formula in parametric. Or this and this could both be g prime of y. And then over here, that would be a dy. Notice the plus. Okay, the plus is because it's a Pythagorean theorem, and Pythagorean theorem is plus. Okay, so that's it. So we can use whichever one of those. This one is our formula. Let's see. Our equation is y equals ln x. So y equals ln x. So y prime equals 1 over x times 1. That's the derivative of the inside. And then I'm going to set it up to be the integral of 1 plus 1 over x squared dx. And then these are going to be x bounds because it says dx. Oops, dx. And then the x bounds are 1 to 2. And you don't have to draw out pictures usually for arc length. So 1 to 2, 1 over x squared. That looks like B, number 4. Yeah, 93%. See, we still want to keep that on the test. You guys rock that question. Okay, ooh, the next one, 56%. So this was a bad question, but that's okay. That's why we're learning how to do it. Maclaurin series. For the function, what is the value of f of 3? Now, they supposedly took off Maclaurin series, but they said Taylor series are still on. So what if they said the Taylor series for the function is given by this? What is the value of f of 3? So you would still have to know how to solve it. So I would say know how to do this one. What is the value of f of 3? Let me plug in some numbers. Interesting. F of 3. I could just plug in 3. Let me just substitute in 3. I was thinking I was going to do something tricky, but I think we should just substitute in 3 for x. Oh, now this looks geometric. Okay. And there's no no option because we're estimating or something like that. So that's awesome. So it's geometric. And let's write out some terms. So I like to substitute. So this is negative 3/4 to the 0 plus negative 3/4 to the 1 plus negative 3/4 to the 2. Okay, I see r plus dot, 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 and it does go to infinity. So we're going to keep going. And then this is 1 plus negative 3/4 plus 9 over 16 plus dot, dot, dot. And then I could probably tell by this step above that this right here and this right here, my r is negative 3/4 because that's what I'm multiplying by each time. Now, is the absolute value of r less than 1? Absolute value has to be less than 1 to use this formula. S equals a1 over 1 minus r. This is only for geometrics, okay? And it's only when this is the case. So I would say absolute value of negative 3/4 is 3/4, which is good. Okay, so let's substitute it in. So S, let me go back to S. So S equals A1. A1 is 1. 1 minus R, negative 3/4. So this would be 1 over, let's change the colors here, plus plus, 4, so 7/4. So that's 1 times 4/7, which would be 4/7. And they said find f of 3, and that was the infinite sum, so it should be 4/7 is the answer, which is C. You might have thought, what the heck are they talking about? And then you gave up. And that's definitely possible. Okay, so sometimes that's going to happen. Just if you still have time at the end, you're going to want to make sure that you go back and still try to find some solutions. Okay? Okay, so that's going to be your plan. Okay, so let's go to the next one. This one. 6. Are we on 6? I think we're on 6. So we are on 6. 96% of you got this right, so almost no one missed it. So you guys are pretty awesome with the substitution. Now, those of you who did miss it, let's see what you put. Oh, I have it shared with just my class. Let me get everybody's here. Let me get everybody's answers. This is number 6. Let's see, an E, and an E, and an A. Okay, so probably you forgot to change the bounds. Okay, so that's what I'm thinking that it was. And let me sort back on my class. Doesn't matter, I just want to see the individual students who, in my class, who got it right and got it wrong. So that's why I'm sorting on them. Okay, so for number 6, your U substitution probably was good. So du over 2x dx. And then x times u to the 5th times dx. And dx is, oh, I wrote this funny. I didn't write equals, so equals dx. And that's equal to du over 2x. Okay, these cancel. But you see how it says du here? That means your bounds have to be u bounds. Now, I don't know how they're going to test you on this concept with free responses. I don't know how they'd say setup only, but it's possible. So you should know this. Not that you do know this, because that's not usually the way we do it in Walnut. Okay, so usually how we do it in Walnut is we don't change the bounds. Usually we go back to x's later. So, but our students here do really well. So whatever way we're teaching you is the right way. Okay, so this is u equals negative 1 squared minus 3. So u equals 1 minus 3, u equals negative 2. And then they go right where they went. So the 4 went with the 13. So you have to put the 13 where the 4 is. And then you have to put the -2. It's not about size. Okay, and then their answer for this one, B's wrong because there's no 2. I do want a 1/2 in the front. Okay, a 1/2 in the front. And then I want the one with the 13 in the 2. So those of you who put E, you didn't notice that you have to change your bounds to U bounds. Okay? Very typical mistake. You learn it before the actual test. That's what you're learning through this time period. Okay. Number 7. Number 7 is a pretty good one. 1 in 10 of you missed it. Okay, so not too bad. Okay, so let's see. You might have forgotten the formula for arcsine, so you just need to study your formulas. Okay, so this one is an implicit. I feel like it's an implicit. Look at all the answer choices. I don't know. These two are just regular x's. And then these have x's and y's. I might do implicit. I might solve for y. I don't know. We'll see. So my two choices are implicit, which would be what's the derivative of arc cosine? That's the same thing as sine inverse. So that's 1 minus the inside squared times the derivative of the inside. Times dx, right, because I'm doing implicit, equals the derivative of ln y is 1 over y times y prime, or times dy. There's different notations you can use for this. And then dy dx, if I divide by the dx, and then what, multiply by the y? Okay, then I'm going to get, let's change over here to red, so that would be y over 1 minus x squared. Those cancel out, and this would be the answer, if the answer is there. Okay, the answer is there. And 7 is A. Now, there is an alternate way. Now, you're not going to be taking a multiple choice here in 2020, but let's see, what if you were trying to match it or something? I'm not sure how they're going to phrase these questions. Let's say E both sides. So you have E to the sine inverse. I like sine inverse notation, equals y. Unless I'm typing, and then I like the other notation. Then I could just do the derivative the regular way, which is E to the sine negative 1x, because it's E to the x, times the derivative of the inside, which would be this, 1 minus x squared times 1. So, oh, I like their answer, except what did they do? What's this the formula for? What's 1 over 1 plus x squared? That is not the formula for sine inverse. That is the derivative of tangent inverse. That's d dx of tangent inverse. So that would be the mistake if you picked E. Okay, you were doing tangent inverse. See the plus sign here? Kind of looks like a T. I don't know if that helps you, but that may help you. Anyway, or maybe not. Okay, let's go to the next page. So we picked A, and that was number 7, so we're good. Okay, number 8. Number 8. Take accumulation functions. Now, they took this off the AB exam this year, but not that they didn't want the students to know it. You did see this last year. Okay, so you saw this last year. Right-hand Riemann sums. Okay, so this is got a whole bunch of stuff in here. Okay, I start with t equals 4 hours. Now, I like to make a little chart, so let me just show you my chart. And it'll help you a lot for the free response. So this is rate, and this is amount. Okay, and amount is the integral of rate, and rate is the derivative. Okay, and so what I do here is this is the start, and then I do in, out, overall. Okay, so there's never a starting rate that matters, so that's not applicable. Okay. That probably looks like an X, so let's not make that look like an X. Let's just say not applicable. Okay, so let's see the information. It says we have 50 liters of oil at time equals 4, so that would be the amount. And then sometimes I'll write over here in my column, T equals 4. So I remember where I'm starting that, because sometimes where you're filling and where you're removing is different. Okay, oil is being pumped into the tank. Okay, so into the tank, in this case, they're calling it R of T. Sometimes they give it a name with a prime. Sometimes they give it no name with a prime. Sometimes they just give it different names. Sometimes they'll give you an equation. So in this case, they gave me this is called R of T. where R of t is measured in liters per hour. Okay, and met t is measured in hours. Selected t values are given. Use a Wright-Riemann sum. What's the approximation for the number of oils at the time 15? Okay, so I do want the integral of the rate. Okay, but I want this box, the overall, and there's none going out. So this is actually 4 plus the integral. And did that say it was 4? No, hold on, I did that wrong. That was 50, wasn't it? Okay, so that was 50. So let's change that. So that's 50 plus the integral of the rate. But the only thing is I need to know the bounds. So they wanted to know 15 hours. So this is 15, but where did I start accumulating? It was at 4. Okay? And then what you were going to do is we're going to do the Riemann sum on this one, on this purple, and then we have to add 50. So probably some of you forgot to add the 50. Okay, so maybe the answer's E. I don't know what the answer is, but maybe the answer's E and you put B, so you forgot to add the 50 in the end. Okay, so that's possible. What number is this one? Number 8. So 65% of you got it right, and the answer eventually is going to be C, but a lot of you put A. Okay, so then that makes sense. Okay, you forgot to add the 50, so you really want to set it up like that. Okay, let me show you another way I think of it sometimes, is I call it an accumulation function. I mean, that's what its real name is, but think of the height at age 15 of a kid would be its height at age 4 plus all the changes in his height, okay, from 4 to 15. And this is the rate. Okay, so H prime is the rate. So that's the R of t. Did they capitalize it? Yeah, usually I like to do it the same way they did. And then H of 4, or the amount at 4. So sometimes I'll use amount, sometimes I'll use H, because I can imagine a little kid growing up. So this would be 50 plus the same thing. So we get the same thing either way that you want to think of it. And then I need to do a Riemann sum. So to do a Riemann sum, I always like to draw a picture. It doesn't have to be to scale, but it helps me see the rectangles. Okay, and then I have a 6.5, a 6.2, 5.9, and a 5.6. So draw your verticals down, and then it says Wright Riemann sum. So Wright Riemann sum means that if I'm dealing with the 4 to 7 section, I'm going to use the 7. Okay, and I'm going to use the 7's height. Okay, for this section. And then for the next section, let me change it to green. I'm going to use this width. And I'm going to use the right of that one, which is this height, and then over would be my rectangle. And then over here, I'm going to use my right one, which is 15, and then that's a rectangle. Okay, so when I set it up, just so I can show my work properly, I'm going to keep the 50, or you can add that later. Okay, is the area, so Riemann sums is each area is base times height. Okay, if you're doing trapezoids, you have to use the other formula. So base times height would be 3 would be the base, and then f of 7. That would be the official work. And then this would be 5 would be the distance between 7 and 12, and then f of 12. And then the distance would be 3, and then that's f of 15. So we can't use that other formula that we had learned. There was a time when we learned other formulas, but we can't use that one because the widths aren't all the same. So this would be 6.2. 5 would, and I'm trying to write these in free response ways because I know this is multiple choice, but we're practicing for a free response test. Okay, and then you have to work those out. Okay, and we're not on the calculator section, so you should be able to remember 5.6 times 3. So 18 carry the 1, that's a 16, that's 1 decimal, no decimals, so this should be 1 decimal, so that would be 16.8, etc. Okay, but I know what the answer is, so I'm just going to take the answer of 114.9. Okay, now if you did get an answer of A, that means you forgot to add the 50. Okay, I'll put a little plus 50 by A. So the answer turns out to be C. Okay, let's see. Which of the following series converge? This is not on. No, I'm not going to say that. That's not true. I was thinking converging's not on there, but that's not true. Okay, so which of the following converge? So I need to use all my tests. So the tests that are on there are ratio, harmonic. They said comparison tests aren't on there. Ratio, harmonic. They said nth term test isn't on there, but that's so strange. They must have been looking at the test, I guess, when they chose. The root test isn't on there, but you can use any test you want. So, I mean, don't feel like you can't use whatever test you want. You know calculus, so just use whatever you want. They're not going to get mad at you for using something that they were thinking that they were going to use something else. Okay? Okay, so limit as n approaches infinity. So I'm going to use the ratio test on this one because I see the factorial. Okay, and let's see how you guys did on this one. Let's see how you did. This is number 9. 73%. So 3 in every 4 people got it right. 1 in every 4 people got it wrong. So definitely we want to go over it. Technically, there is an absolute value. In my class, I don't usually put that until we're doing intervals of convergence. And intervals of convergence are not supposedly on the test. Okay, times n factorial over 8 to the n. Those cancel. And then you expand the higher factorial. So that's n plus 1 times n factorial. What you're doing is you're saying something like 15 factorial is 15 times 14, and then you're saying, oh, let's stop at 13 and say and all the rest. Or 15 times 14 factorial. Or 15 times 14 times 13 times 12 factorial. So this is what I'm doing when I change this. I'll highlight it for you. Oh, that's the eraser. Where's my highlighter? Okay, never mind. Okay. So this is... Oh, I have to change it over here. Okay, let's see how it looks. So that would be this one to change into this. That's what I just did. Go back to the pen. It's funny because all the different tools that I use, if I'm in Microsoft Note, I have a different pen. If I'm in this one, which is write on PDF, it's a different pen. If I'm taking a picture and writing on the picture, it's a different pen. And so that's why the controllers. Okay, so that looks good. And this is still n factorial. And this is an 8. So the n and the n factorial cancel. Limit as n approaches infinity. 8 people. 1 billion donuts. Usually I wouldn't write this on my paper, but I think it in my head. And the same thing with this. So this I think of as donuts over people. Okay. So if you have 8 donuts and 1 billion people, how much do you get? Okay, 8 donuts and 1 billion people, so that's 0. So the limit here is 0. Now, that was supposed to be less than 1 to converge by ratio test. So this converges by ratio test. Oh, I believe alternating series test is also on there. And then they said, what, Taylor? And then I forgot the other one. There's another one that's on there. Okay, so that's converges, which is fine, converge. So 1 converges. So 1 converges. That one's not right. That one's not right. 1 converges. 1 converges. Okay, so I don't know which one I want to try next. I guess I'm going to try 2 next. Okay, so Roman numeral 2 is a factorial or a polynomial. Who's bigger? I think a factorial is bigger. I think I'm going to do a limit. So I'm going to use the nth, and we should label the test we're using. This is the ratio test. So this is the nth term test. I call it the nth term test for divergence because it's only a test that works for divergence. I don't know about the other teachers. Okay, so limit as n approaches infinity. I also call it the direct limit. If you just take the limit from the beginning. Now, the only problem with this one is you have to know your orders of magnitude, because if you don't know your orders of magnitude, you don't know the size, you don't know that this limit is infinity, because the larger one is at the top. This is larger on the orders of magnitude list. And I will write the orders of magnitude list for you. Okay, so, and it's infinity, and if you ever get infinity when you're doing converging, that means it diverges, right? So that diverges. By the nth term test for divergence. Nth term test. Okay. For divergence is what we call it in my class, but you don't have to call it that. I just didn't want them to accidentally say it converges. So if you get 0. Orders of magnitude. Okay, so think of these mixed up. So ln x, n to the 10th, 10 to the n, n to the n, n factorial. So think of these mixed up. Who wins? So imagine you plugged in 1 billion for n. Who wins? Now, the slowest one is the log. Okay, now well, let's do 1,000. So is 1,000 to the 1,000 bigger, or is 10 to the 1,000 bigger? And what about 1,000 factorial? So that's what? 1,000 times 999 times 998, etc. So who's the biggest of those? And then what about 1,000 to the 10th? So exponents win, right? So definitely this is the next one, 10 to the 10th. Well, for me. So this is called a polynomial. Just like x squared would be that one. And then the exponential is next, 10 to the n. Okay, and then the factorial is smaller because it has decreasing numbers. And the n to the n, they all are 1,000. So this is the order, this is the largest, and this is the smallest by orders of magnitude. And you can use that as a reason for limits, not a reason for convergence, but a reason for limits. Okay, so I was taking a limit, and that's how I got that one. So 2 does not work, so I still need to check 3. Okay, so let's see. I'm going to change colors just so I have space somewhere else. Let's see, this one, if I multiply out the denominator, I'm going to get n to the 3rd plus blah, blah, blah. Okay, so then I'm going to use the limit comparison test. Okay, and it's only the important powers that matter. Okay, so I'm going to compare it to n over n cubed, but that's 1 over n squared. P series, that's the other thing that's on this list. On the left, P series. Okay, so this is a P series. P is 2. I think it is of opposite of geometric. So geometric, a 2 would diverge. So this one converges. So that one converges. So if I took the limit, it would converge too. The limit so this one's by the limit comparison test. Limit comparison test. I didn't show all the work for the test. This one was diverges. This was ratio. It says which converge. So that would be 1 and 3. So 1 and 3 would be answer choice D, number 9. 73%. Hey, that's pretty good. You guys are doing pretty good at this. My class, a little worse. We were at 50%. Oh, there's a spider. How cool. There's a spider on my screen. Wait, spider, I want to take a picture. Okay. Oh, spider, go back the other way. Oh, darn. The spider's now in the dark. I don't know if I captured that picture. Did I capture it right on the edge? Oh, I did not. I missed the spider. Okay. I'm not scared of spiders. I kind of like spiders. Let's see. That's it. So let's go to the next one. And what number are we on? I want to just do 10, and then we'll stop this video and then go to the next group, I think. Okay, so number 10. Oh, this one could be a tricky one. So this one makes me nervous. Okay, so it's actually a really straightforward one, but it makes me nervous. And it makes me nervous because I'm on the BC exam. So on the BC exam or in college, you need to look for domain restrictions. Okay, because this might be an improper integral that we just missed because we're going too fast. So is there a domain restriction? T equals 0 would be the domain restriction. So what if I'm going from 1 to 4? Where's 0? Oh, everybody's okay in here, right? So I'm fine. So I can just take the antiderivative. So I'm going to go back here, add a power, divide by the power, substitute in the 1 and the 4. Let's rewrite it first, though. So that's negative 2 over t to the 1/2, which is what? Negative t over the square root of t from 1 to 4. 1 to 4. Substitute in the top, minus negative. Substitute in the bottom bound, which is negative 2 over 2 plus 2 over 1, which is negative 1 plus 2, which is 1. 1 is E. And 93% of you got that one right. So that's pretty awesome. Okay, so I'm going to stop the video here, and then I'm going to do another video for the 11 through 20, or whenever I get to